Okay, so hello everyone. Let us try to solve the section C here. In the section C, we are having the first question, question number 22. Let us discuss this particular question. It says that an air-filled parallel plate capacitor, a parallel plate capacitor in which air is filled, with plate separation 1 millimeter. So we have a parallel plate capacitor like this, okay, and the plate separation was 1 millimeter. Has a capacitance of, this value is, let me confirm, 20 picofarad. So the capacitance was 20 picofarad. Then it is charged to 4 microcoulomb. It is charged to 4 microcoulomb. So initial charge of the capacitor is 4 microcoulomb. Then calculate the amount of work done. Read the question carefully. This is a good question. Easy and good. Once you'll understand the concept, you can easily solve it. It is a good question. The question here is, calculate the amount of work done to pull its plate to a separation of 5 millimeters. So this is the initial condition. Now finally we have the new separation as 5 millimeter. Yeah. So definitely we have done some work. So that work done we have to calculate in this particular question. To pull the separation till 5 millimeters, assume the charge on the plates remains the same. So we have to assume that initially the charge was 4 microcoulomb. Finally also the charge was the same. Okay, the charge is not changing. Finally also the charge. So we consider the situation in which we have just charged the capacitor and we have removed the battery. So once we will charge the capacitor and then remove the battery, then the charge will be same in both the conditions. Okay? So the charge in the second condition is also same, but in the second condition, what is work done by who? Work done by me. So work done by external agency we need to find. है ना? And beta, if you read the question carefully, work done by external agent, chapter number 2 notes, you can easily recall. I told you work done by external agent is equals to change in potential energy. Very simple. We got the point. How to solve this question? So it means we have to find the potential energy difference. Final potential energy minus initial potential energy. Can we find? Very easily. So here initial potential energy will be C we have, Q we have. Q square divided by 2C. Q square divided by 2C. Yes. Initial capacitance was 20 picofarad. है ना? Clear है? The new capacitance, can we check what will be the change in the new capacitance? Okay, so I'm not putting the value here. Initial potential energy will be Q square divided by 2C. Chalo, try to find the initial potential energy. So let us put the value. Q square 4. Let me put it over there. Then after that we have to find the new capacitance also. In this particular case, when the area is same, everything is same, it is changed to 5 millimeter. The distance is changed to 5 millimeter. So let us first find the initial potential energy. So it will be Q square divided by 2C. Q charge is 4. 4 4s are 16. Square of micro, 10 with the power minus 12, divided by 2 into capacitance was 20 pico. 10 with the power minus 12. Pico means 10 with the power minus 12. So you will be getting the value as 0.4 joules. Yes, I hope I'm getting the correct answer. Yes, it is 0.4 joules. ठीक है? Yes, correct. Now final potential energy. For final potential energy, I need the new capacitance beta. है ना? Charge is same. What will be the new capacitance? Can I find from here? New capacitance. New capacitance will be A epsilon. Area is same. We have not discussed anything about area. medium is saying divided by the distance is changed. The distance here is 5 millimeter. Is it 5 times the original? Can we write it as 5 times the initial distance? So can I replace this d as, is this d as 5 times old d? Yes, 1 millimeter 5 times 5 millimeter. So this one is the old capacitance. So the new capacitance will be 20 divided by 5, 4 microfarad. Is this clear? 20 picofarad, 4 picofarad. Okay. Clear? So this is the new capacitance. Now can we find the new potential energy? Q square, Q square, Q square. Is the same. 16 into 10 with the power minus 12 divided by 2 into new capacitance is 4 picofarad. 10 with the power minus 12. This will get cancelled. 4 4s are 16. 4 2s are 2 joules. Yes, 2 joules. Correct. Ekdam correct. Now we have to find the change in potential energy. Whatever change in the potential energy will be the work done by us. Yes, work change in the potential energy will be, actually when the configuration is changed, the potential energy will change. Yes, potential energy is associated with the configuration, and work done by the external agency is change in potential energy. So work done by external agency means work done by you, which is asked in this particular question. Which is asked in this particular question. Work done by external agent will be change in potential energy, final potential energy 2 joules minus initial potential energy 0.4 joules. You will be getting the final answer as 1.6 joules. This much amount of work you have to do, to change the potential energy from 0.4 joules to 2 joules. Clear? Okay. Very good question. Easy question. And then after that we have this, what is the current density? Scalar or vector? It is a vector quantity. Then we have to find this particular relationship in which you have to calculate the current density relationship in terms of relaxation time. So this is just a derivation, you can try it. Then after that we have Wheatstone bridge principle and all, easy question. Now next 24 question. This is theory. This is theory. Okay. Next, this one. Let us understand. A circular coil with constant cross section, with the cross sectional area. There is a circular coil like this, and the cross sectional area is, this area is given as 0.2 centimeter square. You can write it as 0.2 into 10 with the power minus 4 meter square in SI units. Carries a current. The coil is carrying a current. This current value is also given as 4 ampere. Okay. After that we have is kept in the uniform magnetic field of magnitude. The magnetic field magnitude is given as 0.5 Tesla. Then we have normal to the plane of the coil. Magnetic field is normal to the plane of the coil. Means this is telling us about the angle. Magnetic field is normal to the plane of the coil. It means area vector and magnetic field are in the same direction. It means the angle between area vector and magnetic field is 0 degree. This is the data which we can get from this particular line. Then we have the net force on the coil. So if you can recall that derivation of a rectangular coil placed in external magnetic field, in that we have calculated that the next net force will be 0 on the coil. So now here the coil is circular, again the force will be, net force will be 0. Then we have the torque on the coil. Torque can be given as M cross B. M is current into area. So we have to do area cross B. Means we have to find M A B sine theta. Theta is the angle between area vector and magnetic field. What is the angle? 0 degree. Sine 0, 0. Torque will be 0. Torque is also 0. Tau 0. Then we have an average force on each and every electron. Now please understand this particular part. Average force on each electron in the coil due to the magnetic field. We have to find the average force on each electron on the coil due to magnetic field. Now let us understand. This is the coil. Average force on each electron we have to find. in the coil due to the magnetic field. ठीक है. The free electron density. Now magnetic field is in this particular direction. ठीक है. Listen. Let us consider a little element, dl element. ठीक है. If I'll consider a little dl element, whether I'll consider here, I will consider it here, or I will consider it here. The coil is something like this. The coil is something placed in this particular plane. Yes, coil is placed in this particular plane like this. And we are having the magnetic field perpendicular to the coil. Yes, perpendicular to the plane of the coil. Now, if you will draw a coil here and you want to take a section, a length of the, any length in any direction, B will always be perpendicular to that length. Na? So, it means the angle between L, dl vector and magnetic field will always be 90 degrees. Yes, because the plane of the coil and magnetic field is having 90-degree angle. So, in this plane, you can draw any line. In this paper, let's say you are having a paper, you can draw this line, this line, this line, any circle on the circle. You can take any line. That line will have 90 degree with this pen. Is this correct? Because they are in two different planes. So now we have to calculate the average force. Na? We have to calculate the average force on each electron. So to calculate the average force on each electron, let me take a very small length dl. Okay. Then I will find the force on the total wire. I will try to find the force on the average force on the total wire. So if I will take a small length, the force value can be given as I dl cross B. dl cross B. dl and B is always having 90 degrees. So I can write I dl B. This is the small force df. Now to find the total force on each and every section, what I will do, to find the total force on each and every section, I will just integrate. The total force will be integration I dl into B. B is constant, I is constant, you can take them outside. Integration of dl will give me this entire dl will give me the circumference of this particular wire. So the total force will be I into B into the circumference, that is 2 pi r. Clear? So this is the total force, correct? Okay. Now this is the total force acting on an average force acting on this much number of electrons, because in the wire we are having this much number of electrons. The free electron density of the material of the coil is having this much electrons. This is the total average force on this much electrons. Okay, this is the force. Means you can say that force on this much electrons will be this one. So average force on each electron will be, you have to just divide this number with that. So current value is 4 ampere into, then we have B value, which is 0.5 Tesla. Then we have 2 pi into R value, which is radius is, you have to calculate the radius. Can you calculate the radius from the cross sectional area? So you can get the value of R. Okay. After that, you have to divide it with this is the total magnetic field at the total force we have written, divided with this number, 10 with the power 28. Okay. This will give you the force, average force on each and every electron. So with this you will be able to get the force on the average force on each and every electron. Okay. So this was a little bit, I can say a little bit tricky question. If you will go with the simple approach, but you can try it. Okay. Next, then we have draw the graphs showing the variation with the frequency of the circuit. We have to draw the graphs showing the frequency variation. Graphs showing the variation of the following frequency of an AC source. Resistance. What is the resistance? Frequency. If you will change the frequency, the resistance will change? No, there is no change. Resistance will remain same. Capacitive reactance, we all know the graph. XC versus frequency. XC is equals to 1 upon omega C, 1 upon 2 pi FC, inversely proportional graph like this. Then we have inductive reactance, means XL we have to find. So XL graph, we have covered this in the theory lectures also. Inductive reactance, straight line, yes, because XL is equals to omega L. Omega is, you can write it as 2 pi FL. So XL is directly proportional to frequency, yes. So you can easily write, easily draw the graphs, very easy question. A part was easy. B part, can the voltage drop across the inductor or the capacitor in a series LCR circuit be greater than the applied voltage of the AC source? Justify your answer. Can it be possible? So is it possible that the voltage drop across the inductor or capacitor in the LCR circuit will be greater than the applied voltage? So is it possible? What was your answer? So you have to write in the comment box. Okay. So if you have solved so many questions, you can easily tell that this is possible. Why? Because the voltage across the resistor plus voltage inductor minus voltage capacitor, if we are considering the voltage of inductor is greater, squared with the root will give me the net voltage. It is not like that V net is equal to VR plus VL or anything. So this is not just the direct addition. Okay, it is not the direct addition, it is the vector addition. So in the vector addition, if you have solved some numericals, you must have seen that in certain conditions we have this value greater than this value. Okay, so you can explain here that we have vector additions, not the scalar additions. That is why we can have. Then we have state 2 properties of nucleus theory. Density of the nucleus is much lower. This question is completely theoretical question. State 3 postulates theory. Then we have this particular question. Let us take this one. A hydrogen atom de-excites from n level to n minus 1. So this is the n level. This is the n minus 1 level. So there is an atom de-excites from level this to this level. Okay. A hydrogen atom de-excites. We are talking about certain electron in the hydrogen atom which is de-exciting from higher energy state to lower energy state. Show that according to Bohr's theory, the frequency of the radiation emitted is V is, it is written like this, like that. The frequency is nearly equal to alpha divided by n cube. Just listen the question carefully. For large values of n, they have mentioned that you have to take the large values of n. Okay? So we are considering n is much greater than 1. Then after that, this result is exactly agree with that obtained from classical physics, one of the success of the Bohr theory. Chalo, anyways, don't this question is the theory. You'll read it, you'll find it out what is written, but it is not that difficult. So when the electron is coming down, we know that the energy emitted of the emitted radiation can be written as higher energy state minus lower energy state's energy. Yes, so energy of a particular state, you can write it as minus 13.6, because we have taken hydrogen atom, so Z value we will take 1 divided by n square minus this value will be minus 13.6 divided by, in the place of n we have to place n minus 1 whole square. Okay, so I am taking this value outside. This will be positive 13.6. I am taking outside. In the bracket you will be having this term positive 1 upon n minus 1 whole square. This term negative 1 upon n square. Clear? Now just take the LCM. If you will take the LCM beta, 13.6 n square minus n minus 1 whole square divided by n square n minus 1 whole square. ठीक है, क्लियर है? चलो आगे देखते हैं. Then open it, n square minus n square a square plus b square minus 2ab, so it will become plus 2n. ठीक, divided by this one, n square multiplied with a square plus b square minus 2ab. Clear है? 13.6, this will get cancelled. We will be having 2n minus 1 divided by n with the power 4 plus n square minus 2n cube Is this correct? ठीक है, चलो. Now what? This point, till this point, everyone can do. After that, biology students will say that, ma'am, why this question? We are biology students. But anyways, you can do it. Huh? If you'll read the H.C. Verma, in the first chapter, first paragraph, there is a beautiful line written. Okay, I'll tell that line in separate video. But anyways, the summary of that particular story told by H.C. Verma sir, the summary is, mathematics is the language of physics. So whether you are a bio student, a mathematics student, but mathematics is a language of physics. So you'll not be able to understand that physics if you will not understand the language of physics, that is maths. Okay, so anyhow we have to do the maths. Now this very important thing which is written here, n is much greater than 1. N is very large. Okay, if n is very large, so we'll do one trick. What we can do, we can take n outside. So I'm taking n outside. If I'll take n outside, in the bracket we'll be having 2 minus 1 upon n. Okay, here I'm taking n with the power 4 outside. N with the power 4 outside. So in the bracket I'll be having 1. Here I'll be having n square upon n with the power 4. So 1 upon n square. And here after this one I'll be having n cube upon n with the power 4, means 1 upon 2n. Now as beta n is very large, so 1 upon n will be very small. So you can neglect this term, you can neglect this term, you can neglect this term, you can neglect this term. All the terms gone. And question now it is very easy question. So now we'll be having minus is plus 13.6. In the bracket, this is gone and power 3 is left. So you'll be having 2 divided by, here n with the power 3. Then in the bracket 1 and all the things are gone. So we'll be having 2 into 13.6. 2 into 13.6 divided by n cube. You can take this 2 into 13.6 as alpha, where alpha is a constant. So you can take it as alpha divided by n cube. That is the energy. Yes. It's not alpha yet we have just calculated the energy, na? So let us try to find the frequency. This is the energy basically. So energy can be written as h into frequency. Yes, 2 into 13.6 divided by n cube. Now frequency will be 2 into 13.6 divided by h into 1 upon n cube. This term you can take it as alpha. All the things are constant. Divided by n cube is the frequency. Now this is the question asked in this particular part. Done? Easier. It's not difficult. But anyways, after this step you have to just use a little bit common sense. That is why they have written large values of n. Okay. Chalo. Next, the wavelengths of the electromagnetic waves is often correlated with the characteristic size of the system that radiates. Give 2 examples to justify this statement. The wavelength of the electromagnetic wave is often correlated with the characteristic size of the system. Wavelength correlated with the size of the system. You can give the example of ray optics, wave optics, the phenomena which can be visible. So any example you can give here. Long distance radio broadcast, short waveband, theory questions. I am not taking them. Okay, these are just static data based questions. Then we have this section D, case study based question. This one, a lens is transparent medium. A lens is a transparent, means we have to read something about lens. Anyways, let us try to solve the first part here. The first part says that a double convex lens like this. A double convex lens with each face having same radius of curvature. Okay. Made of glass of refractive index n, refractive index is n. We have to find the power. Yes, so we know that power, R values are given. We can apply Lensmaker's formula is equals to refractive index minus 1, and both the parts are having same R value. So when you will approach from here, this is the first face. So that its R value will be in the same direction. You will calculate the R positive Second phase, you are going in that direction, its R value will be opposite from the pole, minus R. So minus of minus R. So the power, which is 1 upon F, will be given as n minus 1 divided by 1 upon R plus 1 upon R, 2 upon R. So the 2 will come outside and R will be here. This is the power, 2 into n minus 1 upon R. 2 into n minus 1 upon R. This one, part A. Okay? A double convex lens of power P. Double convex lens of power P. Each face having same radius of curvature is cut into two equal parts like this. We have just cutted it. Acha, this is the second part. This is the second question. Acha. So in this we have we have just cut into two parts perpendicular to its principal axis. So no doubt the diagram is just like that only. So when you will cut it perpendicular to the principal axis. So this is the lens, this is the principal axis, you have to cut it like that, perpendicular to the principal axis. The power of one part of the lens will be. So what will be the power of the one part of the lens? So when you will cut it, then one part will be like this, yes or no? So one part will be like this, it means in the same formula, in this one only, one R will remain as it is, this R will go like that, but the second face is the straight face. So this will become, this portion will become infinity, yes or no? So the power will be the same formula, n minus 1, 1 upon R minus 1 upon infinity. This will become 0, so it will be n minus 1 divided by R. Initially we were having this one, now we are having this one. It means it is the half of the original power, the new power is half of the original power. Option number A. Okay, sorry, not this part, this one. Option number D. Okay, option number D. Yes. Next one, third. In the third part, option number D, correct. Next we are having third part. The above parts are kept in contact. So we have just, so if you will not be able to understand this now, just read this question. So in this, they have placed the above parts just like that. And we have to find the power of the combination. Power of the combination. Now, how we'll find the power of the combination, beta? If you'll find the powers separately, this one is having this power half, this one will also have the half power. The total power again will be equal to the original power. Yes or no? So you'll be having the same. But anyways, if you want to calculate, you can calculate also. We know that when the two lenses are placed in contact with each other, the total power will be sum of the two powers. Na? So its power, can we write the power number P1? P1 will be n minus 1, 1 upon. Now first phase which we are encountering, if you move from this particular side, the first phase we will be encountering is a straight, so infinite. Then we are having this particular phase, its radius of curvature will be opposite to the incident radiation, so we have to take it as negative. So it will be n minus 1 upon R. Second power, if I want to calculate for the second part, I'll encounter this phase first if I'll go from this particular direction. So it will be same like that. Your power will be n minus 1 upon R. Total power, you have to just add them. So the total power will be 2 times n minus 1 upon R. It was the original power, this one. Yes, this one. Yes or no? So we will be getting the same power here. B will be the correct option. Yes. Then we have this one, this part. Let us try to solve this part also. Fourth part says a double convex lens of power P with each face having same radius of curvature is cut. A double convex lens, each face, this one is also having power P, this one is also having power P. Achha, theek hai. Then we, sorry, not this one. We have only one lens. Let us read the question again. We are having a double convex lens of power P, only one convex lens, not two. Only one convex lens with each face having same R is cut along its principal axis. So we have just cut it like that. The two parts are arranged as shown. So after that we have placed it like that. Yes, the power of the combination. Now we have to find the power of the combination. Now if you will find the power of the combination here, beta, what will be the power of the combination? Now here we know that we have cut it like that, na? So this will reduce the intensity, but the power will be, or the focal length will be doubled. Yes. So power will be, what will be the power over here? the power of this one plus power of this one. The initial one, this part was having p power, this one is having p power, the total power will be p plus p, that is 2p. So the new power will be 2p. Option number C. Okay, clear hai? This is now, let us do the last part, which says that two convex lenses of focal length 60 and 20 centimeters. So these are the two focal lengths are held coaxially in contact with each other. So two lenses having focal length f1 and f2. This one is 60, this one is 20. The power of the combination is, so the power of the combination is 1 upon f1 plus 1 upon f2, because we know that 1 upon total focal length is 1 upon f1 plus 1 upon f2. है ना? Now this 1 upon f can be written as power. So I just placed the formula directly. 1 upon 60 plus 1 upon 20. Okay, just solve it and get the answer. The final answer will be 1 upon 15d. C option. So I hope you got all the answers. So for this one, this third one, we were having the answer as B. Power will remain same, B. Yes, exactly this one. Okay, got all. I hope you got all the parts. Then we have the second case study, this one. In this one, they have discussed about PN junction diode. What the question says, the root mean square value of the alternating voltage applied to the full wave rectifier. So we have a full wave rectifier in which we know we have two diodes. Yes, and we have a center tape transformer here like that, and we have a ground. We draw the ground over here, ground like this. Then we have, okay. The question says the RMS value of the alternating voltage applied to the full wave rectifier is V0 by 2. So we have applied the voltage, its RMS value will be V0 by root 2. Then the root mean square value of the rectified output. When we'll get the output beta, then again no doubt we'll be getting this type of rectified output. Yes, but the RMS value, whether the peak value will change? No, the peak will not change. If the peak will not change, then the RMS will also not change, so it will remain the same. Option number A. Clear? Chalo. Next, if in a full wave rectifier the current in the each diode flows, we know that during the positive cycle this diode starts working, during the negative cycle this diode starts working. So for half cycle one diode works, for the other half cycle another diode works. So current in each diode flows for half cycle, half of the input cycle. Yes, for first half cycle D1 diode works, then D2 works, then D1 works, then D2 works, and so on. If you will take this one as D1 and this one as D2, this is the basic theory. B option. In the full wave rectifier, both diodes are forward biased? No. We know that when the positive half cycle, then this will be forward biased, this will be reverse biased. This will be short circuit, open circuit. In the reverse cycle, this one will be forward biased, this one will be reverse biased. So full wave rectifier, both diodes are forward biased at the same time, both diodes are reverse biased, one diode is forward biased and other is reverse biased at the same time. Yes, correct. Both are forward biased in the first half of the cycle. No. Chalo, next one. This was the sample paper question. Okay, one student asked me also in her doubts. She asked me also and I cleared her doubt also. But anyways, this is one of the, again, it's one of the easy question, not that difficult. The alternating voltage of the frequency of 50 Hertz is applied to half wave rectifier. So we have the frequency applied to the half wave rectifier, then the ripple frequency. Okay, just read the questions, beta. Earlier we were having full wave rectifier, full wave rectifier, full wave rectifier, and suddenly they asked half wave rectifier. So sometimes students make the mistake. You have to just keep this in mind. Okay. In the half wave rectifier, the output is like that. No output for next half, then for first half, then for next half, no output. So the repetition, if you'll see, the repetition will be, this particular cycle is repeating again and again. Yes, for this particular input. If you're having the input like that, then again this section is repeating. If this one is having 50 Hertz frequency, This one will also have 50 hertz. Frequency will remain same in half wave rectifier. In full wave rectifier, frequency will be doubled. So in the half wave rectifier, then the ripple frequency of the output frequency will be same. 50 hertz, 50 hertz, B option. Okay? So just be careful while writing the answers. You have to just be careful. Okay, then the next one, B part. As shown in the figure, is applied to the PN junction diode. This signal is applied to the PN junction diode. Very simple. Just listen, we'll break the signal. Okay? How we will break the signal? Earlier we were having -5, then we were having +5 volts. So when we were having -5 volts, just attach, this is a straight line -5 volts now. So you can consider it as a DC for a short duration. So you have a DC connected here like that for a very short duration, and a negative sign means you can place a negative battery like that. Yes. So once you place a battery negative like that, so you have to place a 5 volt here. Or what you can do, you can place a battery like that and write -5 here. So that was the earlier way was more proper, na? More understandable basically. So this is the 5 volts. Okay. Now here the P of the diode is connected to the negative. So this diode will be open circuit. So you will not get anything for the negative cycle. So for this negative cycle, the output will be 0, nothing. Then the positive cycle will come, means just replace the diode with the battery like this, 5 volt. A positive cycle, positive half means a straight line, a DC of 5 volt for some duration. So for some duration, the diode will be short circuit. So you will be having the battery is present here like that, and whatever voltage you are having here will be present at the output. So in the output you will be having 5 volt, means the output will be from 0 to 5 like that. D option. Clear? Okay. Next. Section E. I can say that this question is the easiest question of this paper. Chalo, let us try the first question. The resistor, what is this? And capacitor. So a resistor and a capacitor are connected in series. So we have studied LCR circuit and we have now RC circuit. And we have RC circuit like that, connected to a battery. Derive the expression of the impedance of the circuit. So whatever you derived for LCR circuit, just remove the L and do the derivation. Simple. Just remove the L from the entire derivation and do the derivation. Then we have, when does the inductor acts as a conductor in the circuit? Inductor acts as a conductor. When an inductor acts as a conductor in the circuit, give reasons for it. We know that when we will connect a DC to the inductor, then the DC starts flowing, inductor will oppose for very small fraction of second. So when the DC will set up, so once the DC is set up, this inductor is just like a wire, just like a conductor. Whatever resistance this inductor is having, you'll have that resistance. So with the DC, inductor behaves like a conductor. Why? Because DC is having 0 frequency and inductor offers inductive reactance, which is omega L, that is 2 pi FL. Once the frequency is 0, the inductance or the opposition offered by inductor will be 0. Yes, no opposition. It will behave like a conducting wire. So it will have certain resistance that you can consider if it is having a certain resistance. So it will behave like a conducting wire. Okay. Then after that, an electric lamp is designed to operate at 110 volt and 11 ampere current. So we have a lamp and the rating is 110 volt and 11 ampere current. Now can we find the resistance of this lamp? Resistance of the lamp will be a voltage divided by current, 10 ohm. This is the resistance of the lamp. After that, the lamp is operated on 220 volt 50 hertz AC source with a coil in series. So we have placed, with this lamp, we have placed a coil in series. A coil means like this. Okay. So we have placed a coil in series and here we are having AC. Then you have to find the inductance of the coil. Find the L value of the coil. Okay. So the coil initially will have some inductance XL. Okay. If you want to consider 1 ton, you can consider 1 ton also. But the answer will not change. 220 volts and 50 hertz. We know that now it becomes like a RL circuit. Yes. In the RL circuit, beta, the impedance can be written as under root of R square plus XL square. What is the impedance? This electric lamp was having the current 11 ampere, na? The rating is 11 ampere, means 11 ampere will flow from here. So 11 ampere we are having, the voltage supply is 220 volt. Now current and voltage will give us the impedance of this particular circuit on this current value, that is the 11 ampere. So the impedance can be written as 220 volt divided by 11 is equal to under root of R value we have calculated 10 square, that is 100, plus XL value. This one will give us 20. Okay, square it, 400 minus 100 is equal to XL whole square. So we'll be having 300 is equal to XL whole square. So XL will be 10 root 3. Okay. XL will be 10 root 3. ठीक है, correct है. Then we have the inductance L value is equal to omega XL is equals to omega L. L value will be is equals to XL, that is 10 root 3 divided by omega, that is 2 pi into frequency, which is 50. So solve it and get the answer. ठीक है. Once let's say you find this particular question very difficult, oh but this is very difficult, how to solve it? Just go for it, yaar. Very easy. Now let us try the next one. This one is draw the label diagram of step-up transformer and working principle. Simple. Explain the 3 causes of energy losses in the notes. The step-up transformer converts low voltage into high voltage. Does it violates the principle of conservation of energy? So we know that when the step-up transformer converts the low voltage to high voltage, in that case you have seen something. Let's say this current is secondary current. Okay, you can take it like that. Secondary current IS. Now here we know that EP upon ES is equals to IS upon IP. So if the primary voltage is less, then the secondary and the secondary voltage is more, it means that primary current will be more and secondary current will be less. So you'll be having EP upon ES is equal to IS upon IP, or you can write EP into IP is equal to ES into IS. Means this multiplication is constant. If at the secondary we are having more voltage, primary less voltage, it means that the secondary will have less current and primary will have more current. So no violation of principle of conservation of energy. You can explain that at the secondary the current will be reduced to compensate the high voltage. Third one, step-up transformer, 200 and 3000 turns. So primary turns 200, secondary turns 3000. Primary and secondary coil, the input voltage given to the primary coil. Input voltage means primary voltage is 90 volts. Then we have to find the output voltage, ES. Can you apply the formula? NP upon NS is equals to EP upon ES. Okay, and calculate the ES value as EP, that is 90 into NS, that is 3000 divided by 200. Just calculate this particular value. It will be 1350. Okay, you just go through the calculations if I made any mistake, but anyways. Chalo. Then we have the current in the primary. is what is the current in the primary? The secondary coil current is 2 ampere. So the secondary current divided by primary current is equals to primary voltage divided by secondary voltage. So can you get the primary current? Primary current we have to calculate now, and the primary coil. So primary current will be Is into Es divided by Ep. Secondary current is 2. Secondary voltage is this one which we have just calculated, divided by the primary voltage is 90. Just solve it and get the answer. Okay. Chalo. $30 ampere. Correct. Yes. You can do by NS upon NP wala formula also you can apply. Chalo, next one. We have to derive an expression of potential energy of an electric dipole in an external electric field. Potential energy of a dipole placed in external electric field. Okay. When it will be minimum, when it will be maximum, formula you will be get it as minus P dot E. Okay. Minus P dot E, potential energy formula. So this is just directly theory. Then we have this question. Let us try to solve this particular question. It says that an electric dipole consists of point charge minus 1 picocoulomb and 1 picocoulomb located at this particular location. Let us try to visualize it. So one is at origin and another is at 33 and 4. So one is at origin and another is at this particular location. The location is 3, 4 in millimeters. So this distance is 3 and this distance is 4 millimeters. Clear? Then this is the dipole, this is the negative charge, minus 1 picocoulomb. This one is plus 1 picocoulomb. Okay? Then we have respectively in the xy plane, this is the x and y plane. After that we have an electric field in the I cap. Electric field is along the x-axis only. That is 1000 volt per meter. Electric field is like that. 1000 volt per meter. Okay. Now the dipole moment, beta, what is the direction of dipole moment? What will be the direction of dipole moment? From negative to positive, it will be like that. It will be like that. This is the direction of dipole moment. This is the direction of electric field. What we need to find? We need to find the torque acting on the dipole. The torque formula we all know. It is P cross E. What is P? Chalo, we'll find it. PE sin theta. What is sin theta? It is the angle between P and E. What is the angle between P and E? We don't know. So let us consider it to be theta. Can we calculate this theta? The same, na? This theta. Can you calculate? We need sin theta. Can you calculate sin theta from this particular triangle? Sin theta. Perpendicular. If this is theta, perpendicular 4 millimeter divided by hypotenuse. If this is 3, this is 4, this will be 5, na? This will be 5 millimeters. So the angle will be 4 by 5. Sorted. Then we have P value. This will be either of the charge. Charge is 1 into 10 with the power minus 12. Pico means minus 12. Into the distance between the two charges. What is the distance between the two charges? This value is 5 millimeter. Means 5 into 10 with the power minus 3. Then we have to write the electric field 1000. Then we have to write the angle, which is 4 by 5. This will get cancelled. This will get cancelled. We'll be having the answer as 4 into 10 with the power minus 12 torque value. Okay. 4 into 10 with the power minus 12. We'll check it one more time. It is picocoulomb. Okay, 10 with the power minus 12. Newton meter. Then direction we need to write better. Definitely this is the magnitude which we have written. Let us find the direction also. This is the magnitude, है ना? Magnitude. Direction will be put your fingers along first vector, curl your fingers along second vector. Simple. First vector is P, second vector is E. Thumb will show the direction of the third vector, inside. X-axis, Y-axis, Z-axis outside, minus Z-axis inside. So the direction will be minus K cap. Very easy. You can easily do it without using any vector. You can directly do this particular question. Okay. After that, we have this particular question in which the electric dipole moment is this one, consisting of this distance is 2a placed. Show that the potential due to the dipole at a point x equals to this one, k p by x square. Potential you have to find. Easy, very easy derivation. Huh? Then we have this particular question. Let us try to find this particular numerical. In this particular numerical, two isolated metallic spheres. So we have two isolated spheres connected with the wire like that. This is the sphere S1, this is the sphere S2. Okay, so we are having two isolated spheres connected with the wire like that. Radii 1 centimeter and 3 centimeter. This one is having 1 centimeter, this one is having 3 centimeter. After that, respectively are charged such that both have same charge density. This one is having same charge density sigma, this one will also have the charge density sigma. They are placed far away from each other, connected by a thin wire. So this is a thin wire connected over here. Calculate the new surface on the sphere 1, new charge on the sphere 1. So when we will connect them, charge redistribution will take place. Charge will flow from higher charge to lower charge. Charge will flow. No, charge will flow from higher potential to lower potential. Okay, and the charge will keep on flowing till the potentials will become same. Chalo. Now let us first of all try to find the charges on both the spheres. This one will have the sigma means charge per unit area. Charge per unit area will give me sigma. So can I find the charge sigma, which is 2 by pi into 10 with the power 9 minus 9 into area of this particular charge sphere will be pi into radius is 1 centimeter, 10 with the power minus 2 whole square. So the charge will be 2 into 10 with the power minus 9 into 10 with the power minus 4. 2 into 10 with the power minus 13 coulombs. Can we find Q2? Chalo, let us find Q2 also. We have to find the initial charges also, na? Q2 value will be sigma into A2. Clear? Sigma is 2 by pi into 10 with the power minus 9. Area will be pi r square. Pi into radius of is 3. 3 into 10 with the power minus 2 whole square. This one we have to take the square of this one. Okay. So we'll be getting pi get cancelled. 2 3s are 6. 9. 2 into 10 with the power minus 9 into 9 into 10 with the power minus 4. 18. 10 with the power minus 13 coulomb. Clear? Yes, correct. Okay. 18. Is this 5 or 3? 3 centimeter. 3 centimeter. Correct. ठीक है, correct है. 3 3s are 9. So 18. ठीक, correct. Now we have just connected them with the wire. Now once you connect them with the wire, charge redistribution will take place till the potential of both the spheres will become same. Till the potential of both the spheres will become same. So what is the potential of a sphere, spherical body? KQ by R. KQ by the radius, है ना? So potential of A, when the potential of the first body will become equals to the potential of the second body, the charge redistribution will take place. What was the total initial charge will be the final initial charge. Means the charge will remain same. The total initial charge will be equals to the total final charge. Law of conservation of charge. What is the total initial charge? It was Q1 plus Q2. That is 18 plus 2. that is 20 into 10 with the power minus 13 coulomb. Final charge will also be like this, be equal to this one only, yes. VA will be K Q1. Now let us consider then after the redistribution, the new charge is Q1 dash and here Q2 dash, some change, some new charge. So the potential will be K Q1 dash divided by the radius, which is 1 centimeter. See, I am not placing 10 with the power minus 2 because it will be cancelled. K, the new charge here is Q2 dash divided by it is 3 centimeter. Centimeter will get cancelled. You will be having Q1 dash is equals to Q2 dash divided by 3. Now this is the first equation I am getting, and I did all these things to get this value. The total charge is 20, है ना? Clear? The charge values will be Q1 dash and Q2 dash, and the sum of the charges, beta, Q1 dash plus Q2 dash will be same as this one, na? It will not change. 20 into 10 with the power minus 13 only. Yes or no? So from here you will get the value of Q2 dash as 3 times Q1. Or what is the charge? We have to calculate the charge on sphere S1, means Q1 value we have to find. So we have to just replace Q2. Q2 is 3 times Q1. So Q1 dash plus 3 times Q1 dash is equals to 20 into 10 with the power minus 13 coulomb. 4 times Q1 dash is equals to this is the new charge on the first sphere. Can you find the new charge on the second sphere also by the same thing? Okay, we just put the value over here. So in this way you can easily find the charges. Okay, so the next question, this one, array of light passing through a triangular prism, show graphically how the angle of deviation varies. You must have did the experiment also for this particular definition of angle of minimum deviation theory question. A ray of light is incident normally on the refracting surface. Chalo, let us understand. We have a prism like this, and there is a light ray which is falling normally on this prism, on this surface like that. Okay, falling normally on the prism surface, 90 degree. Now we know that because here when it is falling on the normal, then it will go straight like that. Yes, it will go straight like that. Is it straight? So no refraction, it will go straight like that. Correct? Angle of incidence 0 means angle of refraction will also be 0. At this point now the refraction will take place. We have to draw a normal over here. So let us draw a normal on the surface. It will be like that. And the light will bend away from the normal like this. Initially the light was going in this particular direction. Bending takes place. So this angle is delta. Deviation. This is the deviation, na? From the original path, the bending. Read the question. A ray of light is incident normally on the reflecting surface of prism of angle A. This prism is having angle A here, and suffers a deviation at the angle delta. This angle, deviation angle is delta. Okay. Prove that the refractive index of the material is refractive index value we have to find. Now very easy. Here no refraction. Here you have to apply Snell's law. Can you apply Snell's law here? Before applying Snell's law, let us try to find the angles. This angle is 90. This angle is 90. This angle is A. This angle will be. What will be this angle? Sum of all the angles. 90 plus A plus, let's say this angle is X, will be 180. So we'll be having X as 90 minus A. Yes, so X will be 90 minus A. 90 minus A. If this angle is 90 minus A, beta, listen carefully. This complete angle is 90. This angle is 90 minus A. So this angle will be A only. Yes. So at this point, let me mark it as B point. At B point, the angle of incidence is A. I'll apply the Snell's law at B. Snell's law at B. So sine of angle of incidence is A divided by sine of angle of refraction. Now the refraction angle will be from normal to the refracted light. This complete angle we needed now. Now listen carefully, beta. Listen carefully. Just see this line, this one, this line. This is the original line, na? Just like this. This is the original line. Yes, this is one line. This is another line. This angle was A. It means this angle will also be A. Correct? Plus this angle will give me the total angle of refraction from normal. The total angle of refraction will be A plus delta. So sine R I can write. Refraction angle is A plus delta. A plus delta. Sin I upon sin R is equal to refractive index of the medium where the light is going, air, and with respect to from where the light is coming. So we have to write the refractive index of air with respect to glass. Light is going from glass to air. Now just reciprocate it. You'll get the answer as sin A plus delta divided by sin A is equals to 1 upon refractive index of air with respect to glass. So this value I will be getting it as refractive index of glass, which was asked in this particular question. Okay, clear? Again, simple calculations, geometry, and the question can be solved easily. Then we have the refractive index of the material of the prism is. So we have a prism over here, and the refractive index is given as √2. If the refracting angle of the prism is this one, angle of prism 60 degrees, you have to find the angle of minimum deviation. Very easy formula. We have the formula here, sine of A plus del minimum, A plus del minimum divided by 2 divided by sine A by 2 is equals to refractive index. This is the formula, na? So just put the values. Sine A is 60 plus del minimum we need to find divided by 2 divided by sine A is 60 divided by 2, 30 is equals to refractive index is √2. Sine 30 is half. This will go there. It will go there. So multiply half here. When you will multiply half here, you will be getting 1 by √2. Correct? So here it will be sine 60 plus del minimum by 2 is equal to half value. See, I will be getting √2 into half. So I will be getting 1 by √2 here. Is this correct? This sine 30 will go there. Sine 30 will go there. Sine 30 is half. So half will be multiplied with √2. So you'll be getting 1 by √2 only, yes or no? So you'll be getting 1 by √2. Chalo. Then after that, we are having sine this value. Sine √2 can be written as, the 1 by √2 can be written as sine 45. So just equate the angles now. You'll be getting the final answer as 60 plus del minimum by 2 is equals to 45 degrees, 90 degree. 60 plus del minimum is equal to 90 degree. So del minimum will be is equals to 30 degrees. 30 degree. Acha, theek hai. Next we are having this one. Chalo, pada hai. Angle of incidence. We have one formula for it, if you can remember it. The angle of incidence can be given as, I cannot remember any formula. Ma'am, you also have to remember the formula. अरे यार वो formula है ना ये, sin I upon sin R, sin I upon sin R, sin I is I, this one ना, A plus del minimum by 2. Okay, chalo. So here the I value, angle of incidence will be del minimum 30 plus 60, 90 divided by 2, 45 degrees. Done, easy peasy, chalo, done. We are about to finish last question. Okay, again this is theory. Okay, you can do it. Why the coherent source of light we have to use? Independent source cannot behave like a coherent source. I have explained it. I have explained this one in the class. Chalo, a beam of light consisting of a known wavelength. Now this is again easy and good question. A beam of light consisting of a known wavelength. We have a known wavelength. Lambda value is 520 nanometer. And unknown wavelength. So there is some unknown wavelength also. That is, I'm taking it as lambda. Okay, this is lambda. Okay, unknown wavelength is lambda. So the known wavelength, I can write it as lambda dash, and this is lambda, which I don't know this wavelength. In the Young's double slit experiment, produces two interference patterns. So two different waves we have used, two different interference patterns you will be getting. Now the pattern is such that the fourth bright fringe of unknown wavelength. How can we write fourth bright fringe for unknown? What is the value of location of bright fringe? It is nd lambda by d. For fourth bright fringe, y4 will be, or you can write y4 for unknown. I am using this one, and for known I will use the dash ones. Okay, so this is an unknown. Y4, fourth bright fringe of the unknown wavelength, fourth bright fringe. So fourth bright fringe, n value whatever given, you have to put that directly. D into lambda we don't know, divided by d. Equation number 1. Fourth bright fringe of unknown wavelength coincides with the fifth bright fringe of known wavelength. Now fifth bright fringe, can we find known wavelength? If we want to write the location, let me use lambda 1. So y51 will be equals to fifth d lambda. We know the lambda? Yes, we know the lambda. It is 520 divided by small d. It says that the fourth bright fringe of unknown is coinciding with fifth bright fringe of unknown. Means the location is same for both. These two values are same, beta. These two values are same. So you can say y4 value of unknown is y5 value of known one. Yes. So just equate them and get the answer. Very simple question. It is 4d lambda we need to find, divided by d is equals to 5d lambda is 520 divided by d. This will get cancelled. This will get cancelled. Lambda will be 5 into 520 divided by 4. 4 ones are 4, 4 threes are 12, 0. And then 5 threes are 15. 5 ones are 5. Is this correct? Done. Finally, we solved the complete paper. If you are finding the paper difficult, do the preparation. You have to do more preparation. It means you have to do more preparation, beta. Okay, so this part I'll not say this is advanced based paper. Some students are saying this is IIT JEE advanced level paper. No, it is not, beta. Advanced level means very advanced. It is normal paper, not advanced level. If you are preparing for IIT JEE, now you have to check that where you are standing. Okay, what is your location? What fringe location? You have to just check it. You have to work accordingly, beta. So see, I'll always tell one thing. You have to keep on doing the hard work until, otherwise you will keep on making the mistakes, and life will keep on telling you, please don't do the mistake. So you have to do the hard work, beta. You have to do a lot of hard work. If you are preparing for JEE, you have to do a lot of hard work if you're finding this paper difficult. If you're finding this paper moderate, then it means you are going on the right track of JEE preparation. But anyways, with the preparation, the hardest things can become easy. Okay, with the hard work only, and hard work with full of dedication. So I'm giving you a lot of all the best for the upcoming biology examination. Thank you so much, beta. Just be motivated, keep on doing the hard work. If in case this paper your finding is not went well, but anyways, no problem. So many papers in life you'll be having. You'll give so many exams. बहुत सारे पेपर देने हैं जिंदगी में. तो आगे वाले पेपर्स की तैयारी करिए, प्लीज प्रिपेयर फॉर द अपकमिंग एग्जामिनेशंस। पीछे जो पेपर छूट गया है उसकी तैयारी से हुई नहीं या वो पेपर अच्छा नहीं हुआ, उसके लिए परेशान होने की बजाय आगे आने वाले पेपर के लिए मेहनत करें, और जो पीछे गलती की है, द मिस्टेक यू डिड इन द पास्ट पेपर, just rectify those mistakes, then you will go like that. Okay, so with lots of wishes, all the very best for the next paper.